I would say that utilities are actually becoming digital service providers through these digital data.
Heute können moderne
Today, modern sensors, meters, and communication infrastructures are already capable of collecting highly granular data, processing, storing, and analyzing it. I would say that in standard practice, there are now applications based on 15-minute values, and of course, they have the advantage of recording load profiles, thereby identifying load peaks. That naturally takes you beyond use cases related solely to billing or pure consumption information, since there is no legal purpose for collecting 15-minute values for those, at least not yet for water and heat meter data or in submetering. Instead, we are now looking at newer use cases, which means truly operating in the field of grid optimization, in the area of anomaly detection, especially within critical infrastructures. There, it becomes essential to read out data more frequently. We can already say that data granularity and frequency differ significantly. In the field of water supply, data requirements are often relatively low. This means data is collected annually, quarterly, or at most monthly to create a water bill. Of course, we see different regulatory drivers, especially in the electricity sector, that come from another direction and collect data at a high frequency, primarily to enable grid management. The two worlds will, of course, continue to converge, but for now, I would say that municipal water supply and electricity metering for grid optimization are still quite far apart. This new data depth and frequency enable additional analysis possibilities beyond traditional billing. Examples include the collection of climate and room comfort data. Especially in office buildings, this is becoming increasingly important. Due to the trend toward working from home, there may be less presence in buildings. This means intelligent lighting and climate control in buildings that are currently unused, so dynamically capturing occupancy schedules. Then, the topic of truly optimizing heating systems within buildings. Here too, data must be collected more frequently than once a month or once a day. This allows operational states in the building to be optimized. In industry, machine monitoring is becoming increasingly important to prevent failures. So this also ties into the topic of predictive maintenance, finding out where I have sensors that have aged significantly and should be replaced before they fail. These are all use cases where highly granular data is needed. Also, the topic of benchmarking between different buildings. Sustainability reporting is becoming increasingly important in buildings. Here too, energy data must be collected frequently. Today, district heating networks are often operated with some overcapacity because operators often don't know how much heat reaches the weakest point since it isn't measured. If there are weak points in the network, but we don't know what supply temperature reaches them, we may end up running the network at unnecessarily high temperatures. And if, on the other hand, we don't know how much energy is being consumed in the buildings, meaning at what return temperature the medium is fed back into the network, then we simply have no way to operate the network optimally. We can also see in municipal utility projects that even a few degrees saved on the supply or return temperature side and an increase in the temperature spread can result in hundreds of thousands of euros in savings in large heating networks. I would say that the topic of leak detection is actually twofold. One part concerns leak detection inside buildings. Significant damage can occur today when leaks are detected too late. This means very high insurance claims, property damage, and expensive renovations. That's why modern meters today include built-in intelligence to detect leaks. That is, after the meter, within the building installation. It's a measure of protection for the building and, of course, for tenants preventing property damage. That's one side inside the building, relevant for metering service providers, for property owners and tenants alike. The second aspect of leak detection concerns distribution networks. This is more relevant for utilities. We've seen in recent cases that major pipe bursts keep occurring in German cities, leading to large amounts of water being lost. On one hand, that means a loss of water, the resource is being wasted, so to speak. And of course, that creates costs. On the other hand, it causes damage to roads, bridges, or even residential buildings, flooded basements, for example. By monitoring these distribution networks in a highly granular way, it becomes possible to detect small leaks before they turn into pipe bursts that cause damage.
Ich würde sagen, Versorger werden tatsächlich durch diese digitalen Daten
Utilities are turning into digital service providers through these digital data. They have the opportunity to unlock new business models, to build much closer customer relationships, and to take on more of an advisory role, moving away from simply supplying and billing for energy or water, toward offering consulting services. For example, actively offering maintenance of customer systems, actively detecting faults, and, if applicable, even offering flexible tariffs. For those who consume heat particularly efficiently, creating additional incentives on the customer side to truly promote energy savings. Then, of course, also for commercial providers within the municipality, offering things like energy management systems, allowing them to collect data more granularly and realize savings. And on the other hand, achieving stronger customer engagement through web portals by providing consumption information and energy-saving goals via web portals or apps. Thus, transferring customer engagement into the digital world, moving away from the annual letter sent with billing information toward a digital service, making the municipality a full digital service provider for its customers.
sozusagen die Kommunale als digitaler Service, Full-Service-Anbieter für den Endkunden.